$5.576 million is actually the training cost of a single run. It does not include synthetic data generation, it does not include personnel cost. Most importantly, it's not including the purchase cost of the GPUs themselves. So if you add up all of these dimensions, personnel, the several iterations to get to the final run, hardware acquisition, you get the usual number of 100 to a couple of $100 million to set this up and run training. DeepSeek used 2,048 Nvidia H800 GPUs. This caused largest single stock drop ever, where Nvidia lost more than $500 billion in a single day, and the US market lost $1.5 trillion, I believe. And you're only talking about DeepSeek, right? We haven't even talked about the broader open source landscape. There is Qwen, which is from Alibaba. There is a growing list of models. There is MiMax, which is another Chinese model, which beats Gemini. Mainstream caught up with DeepSeek because of the Apple Store app, you know?
Welcome to the Apple Intelligence Podcast. My name is Matt Robinson, and I run a publication about AI's impact on finance called AI Street. I'm joined with Francesco Fabozzi. He's research director at Yale International Center for Finance. And I'm also joined by Tharsis Souza, who's a former senior VP at Two Sigma, a lecturer at Columbia, and an author of a new O'Reilly book on LLMs. We're recording this in the week where DeepSeek has made some waves pretty significantly in U.S. markets, and prior to just starting, we were talking about that reaction. And I'm curious, you were talking about how this was sort of out there. Maybe you could give us a lay of the land of, how do you think it's sort of evolved from this standpoint?
First of all, let's just make sure that we get just a quick summary of what happened. Of course, in the couple of last days, DeepSeek R1, which is DeepSeek's reasoning model, was released together with a technical paper outlining the technological innovation, as well as a free application available on Apple Store, right? And that then suddenly became number one in the US and across the globe. And the key figure there was really that they managed to deliver performance on par with the US leading models, but at a fraction of the cost. So there is this figure of $5.5 million, which was the cost reported in the technical report paper, which is 20x cheaper in comparison with the US leading models. And of course, this caused the largest single stock drop ever, where Nvidia lost more than $500 billion in a single day, and the US market lost $1.5 trillion, I believe. So that was pretty remarkable, implication of the release of the paper and the model. And I think two things are being challenged. One is US being the leader in the AI race. Secondly, the need for multi-billion-dollar investments in data centers, GPUs, and overall AI infrastructure. And of course, timing here is a key factor. All of this happened days after the $500 billion Stargate announcement, together with the new administration. So I think that played also a key factor. So how come, the US is announcing a $500 billion investments in AI infrastructure when supposedly a small team of, Chinese scientists managed to do so with $5 million, right? So that's the key headline, which arguably is, of course, it attracts a lot of clicks because it's very shocking. However, I think there is a lot of a controversy here. I think, first of all, when you take a look at the cost, what has been reported, the $5.576 million, is actually the training cost of a single run, right? So if you consider everything that DeepSeek did as far as the architecture, all their innovation in terms of training and inference, the $5.5 million corresponds to the cost to run a single training run, right? It's not including, of course, the multiple research iterations, how they evolve the architecture, the trial and error that happened as they were to come up with the final configuration of the architecture. It does not include synthetic data generation, which was one of the key parts of this new product. In fact, they constructed more than 600,000 data samples that they use for reinforcement learning purposes. This is not included in the $5.5 million. Does not include personnel cost. The paper itself has more than 100 authors, right? It's been claimed that DeepSeek has over 200 employees, so it's not including, the human capital of the story. And I'd argue, most importantly, it's not including the purchase cost of the GPUs themselves, right? Which is very costly. And that's where also there is a lot of misinformation out there. If you read the paper states that DeepSeek used 2,048 Nvidia H800 GPUs, right? So 2,048, which we can talk about, the difference between, H100, the GPUs that are available here in the US and H800. But bottom line is, if you just consider the 2048 H800, assuming an average cost of $30,000, you already have $600,000 there, right?
Mm-hmm.
Sorry, you have $60 million there, right?
Yeah.
That's been spent in GPUs. Now, if you take a look at some Chinese news outlets prior to the DeepSeek R1 release, there are some interviews with DeepSeek's CEO, and they claim that they had already purchased 10,000 A100 GPUs, right? Which were released in 2020. So they purchased years ago, right? And it's hard to estimate the cost at that point in time for DeepSeek, right? But one conservative estimate today would be that each A100 costs on average $10,000. So if you add up these two dimensions, H800s and A100s, you already are over $100 million in hardware cost, right? And of course, there has been claims which are unfounded as of today that DeepSeek might also have the more powerful H100. So we are not even counting that, right? So in terms of hardware setup, there is a lot of cost involved that hasn't been taken into account in the 5 million figure, right? So if you add up all of these dimensions, personnel, the several iterations to get to the final run, hardware acquisition, you get the usual number of, 100 to a couple of $100 million to set this up and run training. And lastly, and I'm going to stop here, we're not even accounting for the inference cost. And that's key because these, thinking models like OpenAI, O1, O3, as well as DeepSeek R1, they run on the basis of test time compute. So they create chains of thoughts at inference time. They think about, possible paths to arrive at a more likely accurate answer. So there's a lot of cost in actually running the model at inference time, right? So how much does it cost to actually maintain this model going forward, right? So again, the 5.5 million figure does not account for that. So bottom line, the 5.5 million figure is misleading. Of course, there has been a lot of technical innovation, which we have to discuss and explore the implications. But it's misleading to stick with the 5.5 million figure as a representation of what one should invest in order to achieve top tier intelligence.
I completely agree. I'm glad you mentioned the inference, because that's what a lot of people don't understand in the market demand, or in the U.S. markets. A lot we saw this tank because there's less demand for chips. The electric companies that are running these electric grids for running these models, they're getting hurt. And what this training says, this more efficient training per se, that you still need the same sort of GPUs for the inference, right? They didn't change anything on the inference side. So now let's talk a little bit more about the more technical aspect. You can give us higher level, but so they've come up with this new training, this reinforcement style learning, which makes that training run more efficient, right? So could you explain the difference between what an OpenAI and other sort of the standard training task that we did, and now DeepSeek's training task?
Sure. There is the reinforcement learning aspect, which perhaps is the most exciting. But the 5 million figure, I would argue, cannot be pinpointed into really a single factor. I would argue it was really hard work from a smart engineering team that really implemented a collection of engineering innovations that alone would not lead to such remarkable efficiency, but when compounded together, led to this 5.5 million result, right? So let me talk first about just a couple of examples of, let's say, engineering, let's say, innovation, and then we can talk a little bit about reinforcement learning, and then really the difference between DeepSeek and OpenAI, in my view. So first, I think the paper really, if you look at one by one, there might be like between 5 to 10 engineering practices that have been put together. They've been working for not like weeks or months. They've been working for over a year on this thing, right? You can find papers that they've been publishing on a regular basis. So you can see how they have been evolving. So it's a lot of work. They have more than 100 people working on this. But I'm gonna pinpoint what I see as the major contributions to efficiency. I think first of all, mix of experts architecture, which is not new. So instead of really having the full network activated, you actually construct a large language model where you have a mix of experts, meaning you have sub parts of the network that are specialized in sub problems, and you only activate a small percentage of the full network at a time. So this brings a lot of efficiency, right? So I think the paper states that the overall network has 671 billion parameters, but at a time you only activate a small percentage, so below 10%, right? So that's one efficiency. That is not new because arguably there has been a lot of discussions around previous versions of OpenAI models that were claimed to be using a mix of experts. So the architecture itself, the idea of the architecture is very old. I would say one could argue it's decades old, right? But really implementing this, yes, it led to a significant efficiency, and also serving this with performance at inference time, it's a big challenge. In fact, if you use DeepSeek's API directly, which I do not recommend, you're gonna get performance in the range of single-digit tokens per second, right? You need to use services like Grok or others who have really optimized the model and inference to really get to better speeds. So it's challenging. Now, a second key factor for efficiency is precision, right? So it's widely known and common practice to take a large model and in floating points 32 precision, and then reduce the precision of the weights to lower precision. So this process is formally called quantization, and that's something that is common practice. If you open Hugging Face, you pick a random model, chances are you're gonna find the original model plus the quantized models, right? And one can very straightforwardly plot, quantization levels against, perplexity or other measures in order to really quantify the effect of reducing precision against performance, right? And then this is common practice today. It's very usual that you might not use the original model, you use the quantized version of the model, because by reducing the precision of how you store the weights, you're gonna get much lower memory requirements, but you're not hurting performance to the same extent. So the cost, it's a cost-effective way of running inference on models, right? Now, that is not common practice at training phase. At training phase, it's much more complex to really, reduce precision. And one innovation here with DeepSeek R1 paper is they managed to use FP8 precision at training time, right? Again, this is not completely new. There is evidence of other open source models using FP8 at training time, but as far as I know, it's the first large scale, evidence of such a practice, right? So that's a second innovation. So it's really precision at training time using FP8 versus FP32. There are many other innovations there. One curious innovation is, which really represents, let's say, hard work, is since they were using the old GPUs, the H800s, they had to really go lower level, right? So in the paper, you will see some optimizations where they don't use CUDA to program. They actually go at the assembly level, PTX, to actually implement at a lower level than CUDA itself, right? So they really try to squeeze the most from the architecture by really implementing in assembly directly, right? So that's really an evidence of really how much they were focused on optimizing, bringing efficiency from the architecture. They didn't have the modern GPUs that we have here in the US, so they really had to squeeze the most from the H800 architecture. So those are three examples. Again, taken in isolation, they are not, let's say, oh, that's a breakthrough, we found AGI. But when you put things together, they compound and then they bring this remarkable efficiency. Now, let me talk about reinforcement learning, which perhaps is the most exciting part of the paper, which you mentioned before. I think, taking one step back, how are these modern LLMs being trained, right? So if you look at ChatGPT 3.0, if you compare with ChatGPT 3.5, which was the model that everybody was excited about, what is the key difference between the two? Actually, arguably, it's not about raw capabilities. It's about post-training, what they did after they trained the model. If you look at both models, they actually have the same size, GPT 3.0 and 3.5. Why is it that 3.5 was so much more successful? It's because OpenAI did two things, and that's where reinforcement learning comes in. First thing was supervised fine-tuning. The goal of supervised fine-tuning at that point in time was to turn what was a next token prediction machine, text completion model, into a model that was useful. And then at that point in time, usefulness was chatbot. So, okay, instead of next token prediction machine, let's really fine-tune the model using supervised fine-tuning such that the model becomes a question answering machine. So it's useful for humans. So that's one thing. And then I'm going to talk about what DeepSeek did as far as SFT. A second thing that they did, OpenAI, was reinforcement learning. In particular, reinforcement learning from human feedback. And that's something that was very exciting at that point in time. What reinforcement learning from human feedback did was, it made the chatbot answers indistinguishable from human answers, right? So let's say from a user experience perspective, which to me was the key innovation of ChatGPT 3.5, was really the user experience, answers from the machine became really human-like. Why is it? It's because OpenAI constructed a preference-based data set where they had humans constructing answers that were labeled as rejected and preferred, right? So for every query, there was like a corresponding human-produced answer. Hey, here's one answer which is correct, but I reject that answer. I don't like it very much. And there is one that is accepted because I prefer that answer, right? And that's what leads the machine to sometimes be apologetic, like, oh, I'm sorry, I cannot answer that question because of X, Y, and Z, right? So we hear a lot these types of answers coming from models like Mistral, for instance, or Gemini sometimes. Others like Grok with K from X, they're not that much apologetic, right? So this is coming from the reinforcement learning story, right? Where humans are giving the tone, the way that the machine will really behave, because the machine now is being rewarded to behave like humans, right? Of course, now things become subjective, right? Now humans in real life are introducing biases to represent what is preferred versus what is rejected, right? But bottom line, ChatGPT 3.5 created these data sets, used reinforcement learning from human feedback to align the model that now was a chatbot into, human preferences. And suddenly, ChatGPT 3.5 exploded because now not only it is useful because of SFT, but also it is human aligned as far as preferences, right? So that's the the reinforcement learning from human feedback part. Now, fast forward 2 years and 3 months later, we have DeepSeek R1, and the innovation there was, all right, do we really need this SFT part? So they created DeepSeek R0, which nobody's talking about, but they actually produced DeepSeek R0 first. And DeepSeek R0 was an experiment where, hey, let's bypass this SFT part. Meaning, let's take the next token prediction machine-based model, and instead of, using supervised fine-tuning to make it useful, speak like, with this format in kind of a conversational way, let's skip that phase and just use reinforcement learning, right? And then there's a second innovation here, which is, all right, producing data sets that are representing what is preferred by humans is kind of challenging. And I don't know what's correct, what's rejected, what's preferred. Let's pick a task where we know how to verify the answer, right? They pick two particular tasks, math and code generation, which can be verified, can be precisely verified. You know whether it's working or not. All right, let us create a bunch of samples that are really giving me preferred answers for these two tasks. Let me use these 600,000 data points that I have constructed, from which I know how to verify, to reward the model. So if the model, the base model, the next token prediction machine model, is giving me the right answer, let me reward the model. And that led to R0, right? And then R0 was powerful, but it had some flaws. Sometimes in its thinking process or in the results, it generated kind of it changed the language in the middle of the process, or the formatting was incorrect. So even though they were, hey, wait a second, there is something here in terms of really focusing on reinforcement learning, they acknowledged that it would be important to add one small step of supervised fine-tuning before the reinforcement learning, right? So they call it code start. Okay, let us have just a small data set for supervised fine-tuning, just to make sure that we have right formatting. Let's call it code. Let's have a code start of the model. I think it was just a few thousand data entries, and then let's focus our energy on the reinforcement learning step. Okay, that led to DeepSeek R1, right? Which, of course, it is the result of this, plus a focus on chain of thoughts, which is something that OpenAI popularized. So R1 and R0, they focus on test time compute, where instead of giving the answer right away, the LLM will reason, which is a very overloaded word, but it will generate, scenarios to achieve candidate answers, and then evaluate those answers in order to come up with a final, recommendation, right? So when you put all of these things together, like focusing on reinforcement learning, on verifiable tasks, a little bit of SFT for a code start, plus a focus on test time compute, and all the efficiency innovation that we talked about, that's it. That's a short summary of DeepSeek R1.
I'm curious, you were talking about costs, right? And how it's very much, very unlikely for it to be, what they had cited in that paper. Part of, I think, sort of the reaction has been how much they're charging for their model. And you had mentioned you wouldn't recommend connecting to their API. So I'm just kind of curious, what made you say that?
Well, okay, so there are two statements there. One is pertaining to cost, and another one pertaining to why I wouldn't recommend connecting directly to their API. So when it comes to cost, or in other words, how much they are charging for their services, I think it's hard to explain because we don't know what their business model is, right? We know that supposedly they are a side project of a hedge fund, right? So at the same time, it's surprising that the side project has a technical paper with over 100 authors. Oh, that's the biggest side project ever, right? But we don't know exactly their business model, right? We don't know the people behind it. We don't know what's the kind of compliance framework around it, right? So when things go wrong, we don't know who to call, right? So when there isn't transparency, I'm not going to be the one recommending to use that kind of service, right? But that's one answer, which is one way to answer the question. Another way to answer that question is, why should you connect to a provider whom you don't know when the model is open source? Just connect to a US company that is serving that model from which you have guarantees in terms of services, right? And regulatory framework around it, right? So that's my recommendation. So I highly recommend you to try DeepSeek, but use Grok. Use Grok with K, with Q, with K, yeah, with Q, like the inference provider, not Elon Musk's service. So use Grok, use Hugging Face inference service, use something that is really is an inference provider on top of the open source model, right? Because you're going to have strong guarantees, and also the performance will be great, will be better, right? In terms of really tokens per second, right? You won't be able to download the mod in your machine because it would require, close to 1 tera memory. But highly recommend connecting with an US inference provider. So that's pertaining to that, and that's because not only the lack of transparency, but also if you read terms of use from DeepSeek, they explicitly state that they can take both input and output to do whatever they want. So they can use that data for whatever purposes, right? So so it's up to you, right? But why should you use directly when you have US alternatives,
other options, yeah.
Inferences, so that's my answer as far as why how to use it or not where to use it, and in terms of cost, it's hard to tell what are their incentives, right? Because we don't have transparency.
Maybe you could talk about how you got into the space. I mean, this is you obviously have a very deep knowledge of LLMs, and how they've developed over the last few years.
So how I got into this space? Well, I don't have a special answer. I think we are all in this space.
Well, not everybody can break down what took place quite to that level of specificity.
But we all should. Those who can't will be lagging behind. I think it's not by chance that the market crashed over $1 trillion. Every single product and service going forward will be, tapping into this. And only those with expertise, not only technical expertise, but also business and strategic dynamics, understanding, will actually survive. Because all our, competitive advantage and value proposition, they're all being questioned. Content creators, writers, software engineers, product managers, hardware providers, hyperscalers. I can't think of anyone that is not being challenged by this.
Right.
So I think education will play a key role. We should all re-educate ourselves around this. So this should not be a mysterious thing that takes the market a month to correct. Should be something that we should pay attention to.
Yeah, because their press release was last Monday, and the market crashed this Monday, or the Monday this week.
So let's talk about timeline, right? So I think the market crashed actually close to when the same day that like the impact on overnight futures, they were already reflecting the technical paper release on the same day, right? The DeepSeek R1. So the reaction from so the DeepSeek R1 reaction was fast, but what was not fast was the reaction from the innovation that was already happening in China. Again, DeepSeek V3, which is the foundation of the innovation of DeepSeek R1, like most of the innovation was already public Christmas Day, which I'd argue again that the timing was intentional. it was already there. In fact, chapter 6 of my draft, the draft of my book, already talks about DeepSeek, already talks about the innovation there, how much they were delivering performance at a fraction of the cost. And then I was already arguing that this is really dramatically challenging US leaders, but nobody was not nobody, but let's say mainstream was not really paying too much attention there. And we're only talking about DeepSeek, right? We haven't even talked about the broader open source landscape. There is Qwen, which is from Alibaba, which before DeepSeek, Qwen was already an open source leader across several tasks. By the way, Qwen released the model yesterday, which is on par with DeepSeek as well. So we got to catch up, right? And there is a growing list of models. There is MiMax, which is another Chinese model, which beats Gemini as far as Gemini's key value proposition, which is reasoning on long context window. MiMax has a perfect score in the lost in the haystack or haystack in the needle in the haystack test at a double of the size of the context window. So I'm talking a lot of specifics here, but if you pick the value proposition of all the key US leading proprietary providers, I would argue there is already a corresponding Chinese model that is beating all of them. It's just that, mainstream is catching up to these things, right? Again, I think mainstream caught up with DeepSeek because of the Apple Store app, That's
Right.
it, that's it. The moment all these other Chinese models release something mainstream, people will pay attention, they will backtrack. Hey, well, what's going on? Let me read the paper, and then people will talk about really the innovation, But we shouldn't pay attention to Apple Store. We should pay attention to the innovation that is happening because the future is already here. It's just not evenly distributed. There is a lag between really the innovation that is happening and all of us catching up. But it's already here.
Yeah, that it's interesting that since they attach this inference, they're providing inference for users. It allows non-technical users to actually play with the model and really understand what these open source models provide. But the App Store specifically, right? You give access to the people. Now people seem to be amazed by that. So very interesting.
Yeah, I'm curious. What do you think with you saying those corresponding Chinese models? What does that do for GPU demand going forward?
And that's the $1 trillion question, right?
Legitimately.
Yes. So, of course, it's very hard to develop an unbiased opinion. Well, it's easy for me, but I'm going to say in terms of really leaders, right? Because all of them, they have a bet either for or against the AI thing and their component and its components, right? So it's really, one should not listen too much to really, let's say, leaders in this space speaking, because of course they're not going to tell you necessarily what it is, but they're going to of course tell you what is in their advantage. That's obvious, right? Now my view is and then I'm also developing my opinion, right, on that. But I think perhaps the key is to think about, what is, first of all, the AI secular trend is still here, right? So nothing changes in terms of really AI really making all of us, creating more wealth, being more productive, scaling everything, right? Now, in the shorter term, what is perhaps a trend that has been solidified by DeepSeek's R1 release and what's going on right now? I think the answer to me is a focus on test time compute. right? Meaning, perhaps there will be more and more a focus on, inference versus training, right? Both OpenAI O1, in fact, Gemini, I think it's called Gemini Thinking or something like this. Gemini also, nobody talks about Gemini, but Gemini also released a reasoning model as well. And by the way, it's pretty good, but nobody talks about it because there isn't an app in the Apple Store. But DeepSeek R1, they're all test time compute models. They're all thinking models. They're all models that are spending loads of time and money and compute at inference time. So, meaning perhaps a shift is compute will go to enable inference versus the previously assumption that all these AI infrastructure funding, Stargates, would go to training bigger, larger, more powerful models. And there are implications. I'm going to wait for you. I'm going to let you ask your question, but there are implications on what changes in terms of infrastructure as we shift from enabling training versus inference. But I'm curious about your question.
No. I was thinking. So, like you were discussing their efficiency from, like you said, all the investment has been into pre-training, and now is it the same amount of compute? It just shifts towards inference.
I think it's hard to answer the question. Like, is it the same amount of compute? It's very, very hard, but we can talk about the drivers of that calculation, right? So first of all, inference is, in terms of compute, inference compute is quote unquote easier than training compute, right? So Nvidia is a monopoly as far as training compute. Technically speaking, it's much harder to really develop training and also run training on hardware. It's much harder than inference. Nvidia does not have a monopoly as far as inference is concerned. That's where firms like Cerebras, Grok are all strategically invested, right? When it comes to training, you have all kinds of things that you need to manage, like intermediary results. There is this gradient descent thing that you need to store some, temporary values, activations, and more importantly, all the chip-to-chip communication that needs to happen at training time. So all these things, NVIDIA became so good at that they suddenly became the most valuable firm, ever, because they develop, expertise. They develop CUDA, which is the software layer on top of this to make it all these complications more user-friendly and manageable and optimizable, so on and so forth, right? So NVIDIA perhaps will continue to dominate the training phase. Now, inference, there are many more players out there, right? And if there is an increased focus on test time compute, therefore, there will be lower needs for training and increased needs for making investments on inference, right? Meaning, perhaps the value is shifting to the application layer, which means AI infrastructure that is enabling the application layer, that is enabling test time compute will win. Well, they were already winning, right? But everybody will continue to win. But perhaps the inference players will win even more, right? And markets, they don't work in the present, they work in the future. So it's all about expectations, right? So everybody will grow. Everybody in AI will grow, right? In AI infrastructure. It's just that as far as expectations are concerned, those from that were offering infrastructural training time compute, perhaps yes, they will grow, but they will grow less. And those offering infrastructure for inference test time compute, they will grow, but they will grow perhaps more, right? So that's the infrastructure play. And of course, there is the application play as well. Now, one could argue more than ever, the cost of intelligence is dropping to zero, which leads to democratizing access to intelligence. So more and more now firms are incentivized to actually build AI applications, which is good for all of us, right? For consumers, for society in general, which is Javon's paradox, right? Which everybody is talking about. So perhaps there will be even more collective usage of compute because compute being intelligence being cheaper, usage will grow. So collectively, there will be more spent in compute, arguably at the inference test time compute phase, a little bit less or much less in the training time phase.
That's how are you keeping the track of all this? How are you keeping track of all these models? Yeah.
It's hard. It's hard. But
I talked to a lot of and you're probably most informed person on this I've spoken to.
I think first of all, when you are excited about something, you really love interacting with that, right? And I love this area. As a computer scientist, my role is being transformed by this trends. So I'm excited about really not only learning but also being a player in this space, and then also making up my own future as well, right? Now, secondly, I think open source community is the best place to be. So when you are contributing to open source, you naturally interact with experts in the area that are solving similar problems that you're solving using similar technology. So you end up being at the forefront. I would argue the open source community already knew about this, perhaps recommendation for analysts out there, be part of the open source community because naturally you're going to be at the cutting edge of these things.
I do think, there's a lack of people who are in both camps, right? There's very few. There's a lot of investor, but there's not a lot of overlap, and that's why you have sort of these timelines that don't seem to make sense. Interesting to your point about. I'm sorry.
Real quick, yeah. Just want So what when you say the open source community, are you typically engaging with people on X, on some other platform? What do you prefer, like a little bit more specifically?
First of all, build something, right? And then publish on GitHub. And it's incredible. By just solving something interesting, using something innovative, people will reach out to you. I won't mention names, but I even had like CEOs of companies reaching out to ask for feedback because I was complaining about them. So, but also other people that, hey, you should be using this instead of that because it's better. So people will reach out to you naturally. And of course, when you reach out to them and then you show something real, they know that you are genuine. And then there is an open dialogue about that, right? So just build something and then make it out in the open. And then these will attract like-minded people. So that's number one. Number two is there are clear winners as far as really community building in open source, and Hugging Face is today is the largest community out there. So just engage with the community there, publish data sets, models on Hugging Face, join their Discord, so on and so forth, right? But I think building something is the best way to engage, and also joining, open source communities out there.
Awesome, thanks.
I was talking about no. I was going to mention because I was talking to some providers or some folks building, and they're sort of agnostic to the model that they're using. Right? They kind of bounce around to different use cases or which works best. I mean, do you see that just continuing?
100%. I think you don't want to run the risk of being tied to a specific provider. So every firm already starts with the strategic direction of being independent. which also brings the question of really how should our infrastructure look like so we are flexible in switching models, which brings the further need of evaluation, right? So when you're swapping models, um, 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 one thing is make it easy to plug and play. Another thing is building domain-specific leaderboards so you can actually evaluate whether the model swap, what are the implications into your use cases, right? So I think this is a strategic. This is a question of strategic importance for every firm today, being model agnostic, but also building domain-specific evals that are targeted at your use case. Because relying on openly available leaderboards is a trap, because not only they are saturated, but also they're solving general purpose problems. Enterprise
Yes.
companies, they have domain-specific problems instead.
So that's a great point. Could you give an example of some sort of evaluation metric or evaluation strategy that you had for one of your projects, or you can run with that how you please?
Yeah. That's chapter 1 of my book because it's so important. I would argue nothing matters if you don't have, an evals framework, because you don't have a definition for success, right? So why should you build something on top of, generative AI products when you don't have a way to actually quantify success in the first place? So every project should start with an evaluation framework. I even argue that, well, now speaking in terms of my product management side, um, uh, that's really kind of really shifting the role of product leaders. Now we have the responsibility of actually defining, data evals as the product requirement, right? So before we were defining requirements for products. Oh, the product should do X, Y, and Z, and we wrote in a piece of paper, and then engineers were implementing those requirements, right? And then engineers implemented unit tests with fixed input and fixed outputs. This is all, lost, right? Because LLM-based products are non-deterministic, they are generative. So all this framework doesn't work anymore. So product managers are now responsible for actually defining data and evolve frameworks that are capturing the generative nature of LLM, the non-deterministic nature of LLMs, and then really quantitatively defining success through these evolve frameworks. Now, how to go about defining evolve frameworks and then picking one real example, perhaps I can talk about very briefly about an experience that I'm just concluding this week, which was a very exciting one where I played a small part in Code.org's mission to democratize computer science education to K-12 students. Code.org has over 50 million users today. It's a philanthropic organization from Seattle. There's a famous video with fellows Mark Zuckerberg and Bill Gates talking about Code.org, and they've been doing amazing work in the past decade. Recently, they have been revamping their products in the world of generative AI in two ways. Number one, educating kids about Gen AI. So I played a very small part in the release of their generative AI unit, where they actually taught about generative AI to educate the next generation. So that's one thing. The second thing is using LLMs themselves to improve the product. So now, if you are trying to learn computer science, you can have a kind of an AI tutor alongside your educational system to help you in your learning process. My job was to learn from them how to really incorporate LLMs into an educational system, but think about really how to deliver that safely, right? Because of course users were kids, right? So LLMs are unsafe by definition, right? They are biased by definition. If you pick DeepSeek today and you asked about the Chinese government, DeepSeek will tell you, hey, let's not talk about that.
Right.
All right? No, literally, try it out. So Gemini will not try to give you health advice. So if you upload your X-ray, it will reject. But Grok and OpenAI will not, right? If you asked Mistral V 0.17b, how to make a bomb, Mistral will give you an answer on how to make a bomb, right? So models in the wild, they are unsafe by default, right? So my cycle at code.org was about, hey, how could we go about actually delivering this next generation of code.org's products in a safe way? So really trying to understand how to define safety as far as data evolves. So can we construct a data set that represents safe and unsafe content? So that's one thing. Secondly, how do we go actually about building? How should the system look like? What are the safety requirements? Because it depends on the user. And it's interesting because the user is a human user and an LLM user. They're both sending messages that could be unsafe. Like the K-12 students, they might be asking dangerous questions, meaning questions that they're not supposed to be, that are unsafe, right? Or simply could be that the school defines that we don't want chatbots interacting with profanity, for instance, right? So the very definition of safety is nuanced, and it depends on the school, for instance, the teacher, right, and the user. So we gotta define requirements from the perspective of the human user. We gotta define requirements from the perspective of the LLM, right? From the LLM, we don't want the LLM providing, of course, not speaking in profanity terms, but also not providing advice that could be explicitly or unintendedly harmful for the kid, right? On the other hand, from the user perspective, we want to keep the conversation, educational, polite, but also the user could also send prompt injection to hack the LLM. So we gotta protect the LLM against the user as well, right? That's also safety. That's interesting, right? So defining the user and then what does the safety requirement mean? It's all part of your evolves framework, and then you codify that into test cases in a data set, right? And then you can try to use off-the-shelf safety filters. There are many out there. Llama Guard from Meta AI is one example. Granite from IBM is another example. At code.org, we end up building our own safety layer using a common technique called LLM as a judge. So we actually use an LLM to judge an LLM and the student query, right? And turns out it was the best in terms of false positive and true positive rates. The cost was pretty similar to those compared to those from proprietary providers, and performance was also comparable in terms of latency as well. And it's in production now and it's running. So that's the solution that is in production today. Yesterday, I actually had a talk. I gave a talk to the larger code.org team, highlighting an opportunity for building leadership in this space, where we talked about, hey, we've built this safety layer, but if you look at the assets, the deliverables, think about it. There is an opportunity for thought leadership because one could release this data set, like the data set that defines or codifies safety, to allow for others, perhaps through reinforcement learning, to align models with that definition of safety, right? So if a firm like Code.org released an open source, an open data set that with rejected and preferred responses pertaining to safety, exactly as we talked about what DeepSeek did and OpenAI did, one could use reinforcement learning to align any model with that definition of safety, right? So I think there is a thought leadership opportunity for firms out there to codify these ambiguous requirements like safety in the shape and form of preferred or preference data sets that can be open for anyone to via reinforcement learning to align their models against those definitions, right? Wouldn't be wonderful if we had like a preference open portal, open data portal where, hey, here's the way that Code.org defines safety, or here's the way that somebody else defines, I don't know, what is the meaning of being helpful, or what is the meaning of being truthful, or what is the meaning of being X, Y, and Z, right? And then show the evidence in terms of performance, and then anybody could align a model against those data sets, right? Of course, there is already something pertaining to that, right? So there are many leaderboards out there with underlying open data. They're not necessarily in the shape and form of, preference data sets, meaning they're not in the shape and form necessarily to be used by a reinforcement learning scheme. But I think reinforcement learning has become so interesting that perhaps there is an opportunity for firms to release, preference data, open data sets out there for others to align their models against, right?
Let's think about now in terms of finance, right? We've got such good LLM stuff, but a lot of us are focused on finance here, and so I'm wondering, what do you think sort of evaluation metrics in finance would look like, or rather, what are the next steps in finance that researchers should be focusing on? There's a lot of papers out there that are focusing on sort of prompting techniques, right? And
Mhm.
not really digging into the underlying models as much. So what would be the next area you see being the a big breakthrough for finance specifically?
Oh, uh, that's a multi-trillion-dollar question. But I think, one, first of all, one should be careful, uh, first of all, because um, the most common phenomenon in LLM-based workflow is setting wrong expectations, and you want to avoid this, right? Because more and more leaders are creating false expectations as far as what's possible.
Mhm.
Just a few are being really cautious about it. So my recommendation would be, before you over promise and before you over invest in how to do more, how to do better, you actually think about what is it that you need as a foundation to be right or not to be fooled. So
Mhm.
my recommendation is, think about the pitfalls first. It's not because I wrote a book about it. I truly believe in that, because I
Well,
I
you
think
wrote the
humans.
book because you kind of went through that, right?
Exactly. And I think humans are machines that try to minimize pain. So the book's about that. But the book's is more a technical thing, right? But from a financial analyst perspective, let's talk about that, right? So how to minimize pain, right? So how to minimize pain if you are a financial knowledge worker using LLMs. First, think about the traps, right? What are the traps, the key traps when using LLMs in your workflow? And it's kind of, they're so clear, right? We just gotta build foundations to really fight against those traps. Number one, look ahead bias. Number two, lost in the middle effects. Number three, distraction effects in LLMs. Number four, hallucination, right? And those are kind of obvious things, but one should not be distracted by the wonderful promised capabilities. I would argue, they should focus on the foundations first. Once you establish a foundation that is really giving you visibility around those pitfalls, okay, you can build confidence on actually doing more, doing better, going faster, being more productive because you're not being fooled, right? Let me just spend a few seconds just defining those four things that I mentioned. So look at bias. Well, that's the main pitfall in finance, right? So I've never seen a backtest that, well, a public backtest that was not moving to the right and up, right? So by definition, backtests are good. Otherwise, nobody would share it with you, right? And the main cause of backtests working is look at bias. So if you try something and that something works in the first attempt, 99% chance you're doing something wrong. Because investing is hard. It's not supposed to be easy. If it was easy, somebody would have found that first, and then you wouldn't have found it, right? So if you're finding, hey, this is working, wait a second, what have I done wrong? And then the number one cause is look at bias. You are using data from the future. And guess what? LLMs, they have look ahead bias by default. So therefore, LLMs are the trappiest tool ever for finance people, right? Now, how to solve look ahead bias? Well, if you know the answer, please tell me, because I'm not aware of a straightforward answer for that. There are ways that you can try to control against that. Like there is a wave of time indexed models out there where by training design that where the cutoff date is. So that's one way to go about it. But of course, this does not scale, right? You might imagine, perhaps it scales, right, with DeepSeek's innovation. I don't know, um, but there are some recent attempts with time index models. Uh, Another way to think about this is what are tasks or capabilities that are less prone to look ahead bias. Okay, let me try to use LLMs on those use cases first. But use LLMs to, hey LLM, give me a signal directly, and then I'm going to trade on the signal. That's a trap, right? It's obviously a trap. Or you do nothing and then you simply try to, oh, give me the sentiment on that company. It's very hard to control where that sentiment is coming from, right? If you use the API or if you use the LLM as is, right? You can try to control this, right? You can try to build your own RAG so you can control the data that you are sending to the context window, and then the context window is influencing the reasoning of the model. You can try to anonymize companies. So instead of really having the stock tickers or the company names in the data set, you try to anonymize companies in the data set. Those are all things that are not bulletproof. They're helping you, right? So you should always be skeptical of the results and not be too overly excited, because LLMs, they do introduce look ahead bias, and one should be very careful.
Yeah.
I think that's one thing with like option two of this market. It's very hard. Most people don't have this level of expertise to just sort of know the nuances of these models, and it's of testing each one. I don't know. It's how do you see things sort of evolving in terms of creating sort of like industry wide, or at least more agreed upon benchmarks for specific tools? Because like as you've talked about, these are unsafe by definition. They're not deterministic. So how do you even go about creating that, like at an industry level?
there are leaderboards out there that are trying to solve for the problem of contamination and saturation. There is, for instance, Live Bench, which is a leaderboard where the the test set is not. It's like every 3 weeks or so they release new data, right? So that helps prevent the model that is being tested itself to actually use that data in the training process, right? Because every single week or the week they're updating the data set, right? So that's one way to go about it. Translating that into finance, you know, that can be translated by something that is very common, which is really before you trust your signal, you have some live data, right? So it's true outsample, right? So I'd argue with LLMs, it is even more critical that you really have live, forward testing before you actually trust your results. So really using live signals, so that's one answer. It's really think about ways to really solve for saturation and contamination by actually using true outsample data. But we only talked about one problem, which is really lookalike bias. LLMs also, they get lost in the middle and they have distraction effects. What are these things? Lost in the middle. I've seen recommendations. Lost in the middle is the fact that the more data you put in the context window, the LLM get lost. They typically remember the beginning and the end. They're like humans, right? Nobody will remember what we're talking about now. They will remember the beginning, like we talk about DeepSeek, and the last concluding part of this podcast, right? LLMs are the same. They typically get lost in the middle, right? I've even heard recommendations of, given that the LLMs get lost in the middle, you should put important stuff, repeat important stuff at the beginning and at the end to avoid LLMs forgetting the important stuff of your prompt, right? That's interesting, right? So billion-dollar investments, and we need to do these tricks, right? But that's lost in the middle. And then the distraction effect is you add to the context window, and then the LLM gets distracted by its own knowledge, right? Because could be that whatever you put in the context window conflicts with the prior knowledge of the LLM, so the LLM gets distracted. It's hard to really the LLM for really think about really, should I consider the in-context learning part of the story? Should I consider the pre-training part of the story? And those are two things that are challenging for LLMs. And then lastly, I also mentioned about hallucination, which is widely known, and that gives emergence of RAGs as a solution because it helps against these things because you provide more contextually relevant information, and also the emergence of leaderboards that are measuring these things quantitatively. There is one called the Facts leaderboard, which is a leaderboard that measures, hallucination. And there is also another leaderboard that measures to what extent an LLM model gets lost in the middle. Which, by the way, the min-max Chinese model, as far as I know, has a perfect score.
I know we covered a lot. One of the deep and DeepSeek for good reason, but I'm just curious if there's any sort of thing that we didn't touch upon.
No, I think you also talked about really where should we place our energy going forward, right? And also, our colleagues working in the financial industry in particular. And my answer is really look at the trends that are here to stay, right? Number one, price of intelligence going to zero. Number two, human agency. As intelligence cost goes to zero, there is increased human agency. What does it mean as far as our daily lives? There is a new way to prioritize problems to solve. There is a new way to think about really where we have value add as humans. we should think about really what is it that is very hard or even impossible to do today that will suddenly become possible as models get stronger. All right, that's what you should tackle today, right? So when you think about your workflow as a financial analyst, a portfolio manager, as a quant, as a product manager, what is it? What is that is so hard for you to do that this is really, I have a lot of friction, or I don't have the expertise, or my peers don't have the expertise, or I don't have the tools. We don't have the intelligence. But if models continue to improve as far as intelligence, as far as efficiency, the way that they are improving, which is remarkable, okay, it's gonna become solvable. Okay, that's it. That's what you should focus on. Because when that becomes solvable, you're gonna be the first one, right? And then you go like this, and then you keep innovating for the future, as opposed to waiting for the thing to happen and then only react, right? So that's my recommendation. It's one way to think about really what to prioritize as we work as knowledge workers in this new, extremely fast-paced world.
That's great. Well, Tharsis, Francesco, this was, I don't know, wish we could do this on a regular basis. It's been really helpful.
Yeah.
Thanks for joining us on the Alpha Intelligence Podcast.